Welcome back to the shop, guys. Finally a video on the Z-axis conversion to CNC on the mill, and then eventually I'll show a video when I get some things settled down here on machining something, actually doing something with it. But first of all, some things that I learned, and part of the reason why I gotta get something settled down. Backlash. Evidently, Mach 3, the program itself does not handle backlash. It has a setting for it, but it expects the driver, like the parallel driver, which they wrote, handles the backlash. I guess the driver is looking at what direction you want to go, and then it plugs in the backlash number, taking up the slack. The SainSmart 4-axis CNC control card uses a DLL for USB, for the USB driver, R&R motion .dll, and it does not have the capability to handle backlash. I've told SainSmart about it because I've looked at a lot of different boards. None of them mention whether they do handle it or don't. There is one board out of China, very expensive, that says they do take care of backlash. So if SainSmart fixes this, they would have the entire market, because their board is inexpensive and it would do everything. The other kind of crazy thing is Mach 3 in, I think it was the diagnostics tab, you can calibrate an axis. In other words, you say, I want to calibrate X. You tell X, I want it to move 1 inch, and then it moves, and then it asks how far did it go. And from there it does the math and plugs it in as far as steps per inch or whatever. I have no clue how it comes up with these wacko numbers. I mean, mine came up at first with what? 26039.55341. This is a 16 TPI lead screw. Motors are set for 1600 steps per revolution. You want to move 1 inch, you move the lead screw 16 times. So 16 times 1600, and you plug that in and it works. So I don't know where they're coming up with these numbers. So I manually did X and Y because I know the TPI. The Z, I have to just use their number. It's 46268.42105. Hope it's right. It looks like it with indicator, dial indicator. Do have everything documented if anybody's interested. What else is there? Oh yeah, I had to take the thing apart because I was wondering why X and Y, and especially Y, was so hard to turn. The motor could do it, but just something was wrong, and I discovered, I took the whole thing apart, the Y-axis, I've got the lead screw in there with nothing on it, it's fed in the nut, and I tighten the nut down and the lead screw tilts. So the nut is threaded crooked. Luckily, I did have another nut, a spare one, put it in there, tightened it down, and the lead screw didn't angle. So it works beautifully. And I had the same problem on the X, but I shimmed it to straighten the nut out. So the threads were straight, and it works beautifully now. So again, I'm just turning the camera on as I'm figuring out how I'm going to do Z. So here you go, and see you next time. This one is a lot different, let me tell you, because everything is in the way. Took out the lock handle thing that locks the vertical as Z-axis. No matter what I do, because the motor size, that's going to be in the way. So did the best. Oh yeah, this guy, I wish he just came right out. I'm looking at the picture of it on Grizzly, and it looks like the spline goes all the way through. So either I've got a burr on it that I can't get it out, or the spline doesn't go all the way through. In any case, Grizzly, $5.50. I can get another one because I'm going to cut it and then turn it down for the coupling. That'll be done. So what I did was a giant chunk of aluminum here, gave my face here, so now I got two datums. Did the best I could to measure everything, and I'm pretty sure I've got it on the money because it's sitting on the stud. Once I know exactly where that is, then I can do the 4 holes for the motor. But and I'm starting this way because I had already screwed up once, not realizing the motor goes over further. So plenty of material here. You know, I was going to do the holes first and then cut the material around that to fit this spot. And it looks like I don't need to touch the top. I'm like right there. And I knew it was going to overhang slightly. So my plan is to just notch that out and notch the whole back edge so it can sit. Eventually I do want to cut it at 60s or something like that so it looks like the other piece. But boy, is this a lot of machining is going to happen, because I got to take, probably I'm just going to take this side open so I can get into the coupling to tighten it. So I just need to I tried to put a screw in there, but the screw isn't long enough, so it's angling the block and it won't get the screw started. I need to make another stud to make sure I've got both holes right on it, but I'm pretty sure, flashlight looking through there, I'm right there. And I'm only a few thousandths bigger on this hole. So I guess I'll make the other stud, double check, look at everything, then just do the 4 holes. Because you can see this is pretty oversized here. These guys go all the way in there and just kind of sink, because the motor covers part of this hole. So you just bolt it on there and then bolt the motor down, and then go in from the back, tighten the coupling. So yeah, probably do a pretty good 45 on these edges and a 60 degree, make it look a little sexy. This is thicker than the other one that I did for the Y-axis. So onward and upward, I guess. Yeah, just doing a little work on the Z. I wanted the block a little bit thinner. And I'm not about to fly cut that much material off, so just let this guy go. But a lot of people have emailed me asking, you know, where do I get my material? Well, I have a local supply house called Industrial Metal Supply, and they sell pre-cut stuff by the foot or 2 feet, you know, per pound. This block, though, today I went there for one reason. They have an annual cleaning out where I picked up over $100 worth of material, rod and bar and all that junk, for $2.11. You gotta love it. This was part of a huge block that I picked up. So if you're looking for material, you know, I buy it off of Amazon. Well, I buy it from Industrial Metal Supply first. If they don't have it, or it's something unique like titanium, I'll go to Amazon or eBay. But look up in your yellow pages or Google, you know, look for a metal supply place in your own town, your own city. See what they have. So the other thing is, a few people have asked me how much pressure I put on this to do the cutting. Well, basically, you can see the chip. I put enough of pressure on it until you see nice sized chunk chips coming off. My speed right now is at what, 1.5. I used to go the recommended feet per minute or whatever you call it. It's like, you know, it's just breaking blades. And I have a weight. I'll pan the camera up here. You can see there's just a lead weight on there. That's 2 or 3 pounds. I have a second one sitting. Oh, you can see it now down there on the left. If I want to put more weight on it, but when I do put more weight on it, you start hearing that splice in the blade go whack, whack, and that bothers me. So I just wanted to share this for what it's worth. Might help somebody. Slowly but surely getting there. So, all right. So where am I? Yeah, I had to get this guy out. Evidently, because it was stuck. I couldn't get it out. So I'm wondering if there was a collar or something on the inside But looking on the Grizzly site at the replacement parts, oh, I chowdered it up. It's straight through, so I had to put a pair of vice grips on it, and it looks like I've messed up some of it. Should be okay, but I had to put a piece of wood here and pry it out with a screwdriver because there's like burrs on it, which is what was holding it. So got that out, and I have one on order. Grizzly was out of stock. They wanted $550. LMS had it $1550. Great. So that's on the way. Meanwhile, after a week's worth of work, got it. And it looks like everything lines right up. I've got access to lock down the coupling in the back. I'm going to use one of the existent motors that I have for the other two axes. Make sure that it can run it strong enough. Otherwise, I'll have to steal one off the lathe. I've got a huge motor that I don't need on that lathe. Just swap them out. So that's where I am so far. Wind up painting it here green so that it matches, and everything lines right up, man. I'm thrilled with it. Screw goes, it falls down. Screw goes right in there and hits the holes. Have the print all updated. I did screw up the countersink or the recess here for the two Gibbs screws that are on the back, but alright, so man, that was a lot of chips and a lot of hours, and I did manage to do the boring completely on the mill. It didn't get chatter like I did on the other one for some reason, but alright, let's wait for the part now. Closer and closer. This went way easier than I thought. So you can see I'm just powering it with a 12-volt wall little adapter thing here. This is the Sane Smart 4-axis control board, and it is really nice. It's being completely powered through the USB right now. So it's generating the 5-volt signals and stuff for the pulse and direction and all that hoo-ha, which I really like. And it is beautifully compatible. I mean, you've got the +5 here for this, and then all the signals are in the perfect row, ready to go. And so I wired it up to the X-axis motor. I did all of this on the bench. I highly recommend don't connect the motor to the mill yet. Do all your tuning and stuff like that, where you have up in here configure motor tuning and stuff, so you have your velocities and accelerations correct before you even bother to do anything. There's Mach 3. I've had it for a long time, but I just retired it because I was going to use it on the lathe, and software just was not there. So I'm in step jog mode here. Yeah, a lot of people don't even know. You just hit the tab key and you can bring up your MPG manual here. Step jog, I'm just going to tell it to go to the right. Actually, I'll tell it to go left 1 inch. And so I've got, you know, the 1 revolution of the lead screw is 62.5 thou. Forgot where I was at. I think I'm at micro stepping at 1600 per revolution. So this easily does 1/10 of 1,000 accuracy. There's still a lot more to go. What did I say when to do? Yeah, go left. Okay, there you go. So it's going to go left exactly 1 inch. Yeah, you can see the numbers moving here. There it is. Because I did do some checking here, and it'll do 1/10 of 1 thou. So I don't know if there's that much accuracy in this lead screw, but so it's going nice. So now I need to just simply, I'm just going to cut up this plastic, mount everybody cleanly, start wiring it up. But the other motor that I have this size, I'm going to put on the Z right now and see if it can handle the forces that it takes to move that rack and pinion thing. And if it can't, then I'll try the heavier motor off the lathe, and then put, and now eventually, yeah, I guess I'll have to buy another motor anyway, so I might as well order it, right? Yeah, because I'll need, yeah, I need to buy one more motor. So far, I'm into this $112. So, and this guy, I guess I'll put a link in the description to it, $60. It's on Amazon, or you can buy it from SaneSmart. Beautiful board, and it's got tons of inputs. I definitely need to do something for e-stop to do it. So I'm really thrilled with this. It's now coming together pretty fast. Well, decided to actually just try the Z here. I told it to move 10 thousandths and it's moving a long ways, but the motor can do it. Whoops, I thought green was up. So, let me try, let's see, 5 thousandths, 0.05. No, I had 0.1, yeah, that was 10 thousandths. Oh, I don't want to do that. No. Yeah, 0.01 is 10 thousandths. Okay, so let's just go 1, huh? 0.001. Enter. So I may have to wind up gearing this thing. Oh, that's pretty interesting, huh? So I'm at 16 volts. I've set the unit for, I think it was 2.5 amps. It didn't want to work at 2. I'm at 2.8 amps because it's a 2.8 amp motor. I don't know why it's only drawing 350 milliamps right now, but I wonder if it'll work on 12 volts. Take it down. There's almost 12. What was that noise? Yeah, it works at 12 volts, including up. So, I don't know how I have to put a micrometer on it and see how much that's moving. I may have to set this thing for further micro stepping because this is set for 1600, but this little motor can do it. Interesting. So yeah, I need to play around off camera and just kind of get it figured out and calibrated how many steps per thousandth or so. Cool though, but this little motor will do it. It's got the strength. Okay, kind of have everything mounted up. Fine-tuning the motors. I got X and Y's going. You can see everything's mounted down. But it's a matter of getting the correct accelerations and velocities for it. And directions too. So I've got nice continuous jog here. Eventually I'll get into the accuracy. There's the Y-axis moves. And it's pretty clean sounding. Looks like I'm pretty far back this way. Yeah, I gotta go way back there. Ooh, good. Yeah, because I can't, this nut and everything's blocking me from tightening down the last screw or cap head on the adapter, the flex thing. But this is pretty cool. Now it's just, I can fine tune it a little bit more, but I will do that later on. 1600 pulses per, yeah, okay, yeah. X, I think, well, next I've got to calibrate everything, make sure I have the distances correct now that it's running. So calibrate X and Y and figure out what voltage I really need for a power supply. I know these things are rated up to 40 volts. Right now, I think you can probably see the power supply. It's 15.5 volts. And so this is pretty cool. Still not sure whether, oh yeah. The Z, I had the acceleration way too high, so if I take it down, it'll be a lot better. But, so there it is so far. Cool. Well, I'm pretty close to being calibrated. I'm still waiting for Amazon to give me the Z motor, but so here goes nothing. This was FreeCAD. I just had a 2-inch piece of wood or whatever and said I want a spiral or helix, a hole in it, a 1-inch hole. So it's cranking it away, head's moving, and here we go. There's the spiral. It's doing a circle. Yep, it sure is. That is pretty cool. So closer and closer. And I'm running, what, 16? Probably can go 24, but do have it calibrated pretty close. You know, you say move 100 thousandths, it moves pretty close to 100 thousandths. It's a few thousandths off, but that's cool. All right, I'll stop this thing there. All right, closer and closer. Hoping this is what I think it is. Excuse my voice. I woke up Christmas morning with a screaming sore throat. Transfer punches from Harbor Freight. They're kind of nice. This is a heavy box, so I don't know whether I'm going to return them or keep them. This was a 1/4 inch. It's 5 thousandths oversized. It would have been nice if they were closer, but I only measured one. Where's the other stuff here? Just in case I get into doing Acme threads. This guy is loaded with oil. But here's the thread checker. Get rid of that. Oh well. So I'm hoping this. I saw Stefan Gothwinter with this one particular company's chuck. And ordered it here. I think this is it, huh? Oh, no, this isn't it. I don't know what this is. This is a strange size. Made in China. This could be it, huh? Ow. Ah. What in the world is this? Jeez, and we taped it everywhere, huh? Yeah, I think that's it. Oh. Okay, this is for the mill. I ordered a chuck, and I was expecting a chuck. This is for the Z-axis stepper motor. 100-to-1. That should give me plenty of room. And again, this is not... They advertise this for a NEMA 23. Wow, how does it come out? I need needle nose. NEMA 23 motor, and it has nothing to do with a NEMA 23 motor other than the bolt holes. Because you cannot put the shaft in here. There it is. Wow, teeny little gear, huh? So this would be fun. I'm turning it, right? Yeah. Boy, that shaft is barely moving. So, gonna have to change this shaft. I gotta see if I can take it apart, turn this down to a 1/4 inch so it'll fit the thing, shorten it up. And then this guy, I gotta figure out if I can drill it out. That gear is so small, I don't think I can drill that. I don't know what I'm gonna do yet. But it's plugged, and I'd hate to modify the motor. So, let's see. All right, voice is all screwed up. Woke up with a nice cold. Okay, so you saw from the previous video, NEMA 23 isn't strong enough to run the Z-axis. So, went looking and found they make these little transmission thingies here. So I bought one. It was a 3-to-1. So 3 revolutions every one. And when I got it, you look at it, because it's advertised as a NEMA 23 stepper motor thingy or whatever. So you figure it's just going to go in there. No. I'm not taking this off, but this goes right in here. There's no play. It's amazing. The gear was bigger than this one, but it's just press fit into this. So there's no way you're getting the shaft into it. You have to cut the shaft off. And the actual opening here on all of them is for an 8mm motor. So yes, there are 8mm NEMA 24 shaft motors. So you just cut it off and stick it in there. I already bought the 1/4" shaft, so I've made a sleeve in there, cut the thing off, got it in there, put it in the mill, manually spin it, and it's true as far as my eyeball can see. So a lot of work doing that. What was the work? Oh, the work was making this sleeve. First sleeve, complete failure. It's amazing how much 1/1000th oversized hole plays around. Second failure, this is the third. I decided to make it all press fit. So the sleeve is press fit on the shaft, this is press fit on the sleeve, and everything lines up perfectly. And I got the lengths right. This is a paint, there it is. Okay, so now I have that for the Z-axis. Now, the 3-to-1, if I figured I'm going to have to drill, well, I was originally going to just drill it out for the shaft. But I figured if I'm going to destroy this thing, because you can't get more parts, let me get a better one. This is 100-to-1. 100 revolutions, 1 revolution. So this should give me the torque I need and precision to 1,000 is probably way better than that. So return the other one. I'm still getting ripped off by them. I haven't got a refund. It's over a month now. And the tracking says it was delivered. So Amazon's not even backing me up. Sucks. $60. This was also 60 from a different supplier. So this one, the gear's too small. The outside diameter of the gear is 1/4 inch. So that's why I had to do all this sleeve junk. Okay, so now I got the 100-to-1. This is an 8mm shaft poking way out. Now I got to get that to my 1/4 inch coupling. So I just now finished cutting it off and turning it down. It is a pretty hard shaft to turn, especially with a giant keyway in it, because you smash your insert. And this guy, I was using a traditional TCMT type carbide insert, and it broke one corner off. Spun it around, it broke the other corner off. So I decided to try this one. And this guy, I'm pretty sure it was Dan's Hobbies, turned me onto this. He sent me one insert. This thing, I said before, loves stainless, and it loves hardened steel. It just does a beautiful job. So now I have that, and it's ready to go on. Because this slides in, oh yeah, on this guy, I could not believe that is not parallel to that. Because I put this in the 4-jaw, dial indicated, I think, yeah, it was this. No, I actually said I want to dial indicate the shaft. Got it within a half thou. I had to turn this down because that is way bigger than that, which I made the part on the mill right now to fit. So I had to turn that down, and that was way off. And you can see here, I don't know if you can really see it, but yeah, it cut in here more than over here, so it's tilted this way. But I turned this, and it's down to that size, 1.5 inch. Turn this all down. Ew, junk I gotta clean out. But I'm set. I already just set everything on the machine, and it all seats perfectly. So now it's a matter of just taking it, bolting it all together on there and getting the motor hooked back up, and let's see what happens.